Good morning, guys. Today we're going to continue our conversation about transformations. So this will match your worksheet 1.3 part C. So we're going to look at what happens now when we multiply the function by different things. So again, I'm going to start out by putting a parent function in here. I'm going to use x squared. So x squared is this quadratic, right? I'm going to see what happens then if I put a negative in front of that. So if I do negative x squared, okay, notice here that it's the same function, but it's been flipped. Okay, so let's do a couple more of these. If I do x squared and I add 3 on the outside, it should go up 3, right? So here, it's the green one. Now if I put a negative in front of that, so negative x squared plus 3. Notice it flipped it, and it flipped it that y direction, so about the y-axis, although notice that it didn't flip it actually across the y-axis, because if it did, it would have been down here. So basically it flips first, and then you move it up 3. So flip it, move it up 3. Okay. So a negative on the outside is going to just flip the function over. So whatever point it was at before, it's going to flip over and still be at the same point. So now let's look at one to see what happens if I put the negative on the inside. So for this one, let's use the square root of x. So we'll do square root x as our parent function. So that's this black one here. Remember, it's at 0, 0 and has that kind of arc that goes over. If I put the negative on the inside of the square root, so square root of negative x. Now notice that it reflected, but it reflected across the x-axis, or sorry, no, the y-axis that time. Last time it was reflecting across the x-axis. I think I said that wrong. So this one reflects across the y-axis. It reflects side to side. So remember, everything that happens on the inside with x is a side-to-side change, and the reflection is the same thing. It is a side-to-side reflection. And then if it's on the outside, it's going to be an up and down reflection. So I'll do that one too. So see how that one reflected across the x-axis instead of the y-axis. So if it's on the outside, it's a change that is up and down. It's along the y-axis. If it's on the inside, it's a change side to side. Just like a slide is on the inside is right and left, and a slide on the outside is up and down. That's what we learned yesterday. Okay. We might as well finish this off by making the other part of our little design here. If I put a negative on the outside and the inside, it's going to reflect both directions. And so we'll get that green one right there. Okay. So that's what putting a negative in front is it's the same as multiplying by -1 on the outside or on the inside. It's going to be a reflection. If it's on the outside, it reflects up, down. If it's on the inside, it reflects side to side. Let's actually look at one of these that's slid as well. So I've got the square root of x. I've got the square root of negative x. That one's going to reflect to the side, right? If I were to slide that as well, so let's slide it up. So if I have square root of negative x, and then I come out of the absolute value and do it on the outside, this should move up 3, but it will still be reflected. Okay. If it goes side to side, it's going to actually probably confuse you, so I won't do that. Okay, so now we're going to talk about what happens if I multiply a number out front, and I'm going to go, maybe we'll do absolute value of x for this one. So there's my parent function, absolute value of x. Now if I multiply a number on the outside, like 4, okay, notice that that made this a lot skinnier. And remember, if something is on the outside, it's a change on the y-axis, so it's a change up and down. So think of it as like a rubber band that got stretched up. Okay, so if I multiply it by a number on the outside of the function, it's going to take and stretch that function up, kind of like a rubber band. That's why it got skinnier and taller, kind of. So that is called a vertical stretch. So this would be a vertical stretch by 4. Now if I do the same thing on the inside, notice here that that's the same line, right? So it's the same line, but now that it's on the inside, we don't call it a vertical stretch anymore because an inside change is a side-to-side change, right? It's a change along the x-axis. So we would actually call that a horizontal compression. When you compress something together, you're pushing it together, right? So that's a horizontal compression if it's on the inside. But notice that the graph looks the same either way. Okay, so that's kind of hopefully not too bad. If I multiply by a fraction on the outside, so like 0.5, and then do absolute value of x, okay, now that's the black one. So now it got wider, and if that 0.5 is on the outside, that means it's a change along the y-axis. So it's like taking and pressing down. It's a compression, made it wider, okay? Think of a rubber band. If you press it down, the circle gets bigger around. So that's what's happening is we would call that a vertical compression. So anything that happens outside is happening vertically. It's happening along the y-axis. Anything that happens inside is happening horizontally. It's going to go back and forth on the x-axis. So if I were to do the same thing on the inside, again, it's going to look the same, but now it's not considered, see, it covered it up. It's this red one. So it looks the same, but it's considered a little bit differently because now it's inside. So now it's a side-to-side change. So it's called a horizontal stretch if that 0.5 is on the inside. So notice that if it's on the outside, the 4, that's a vertical compression. Let's write this down. So this is a vertical change because it's on that 4 is on the outside, right? So we call it a vertical stretch. And a number that's bigger than 1, like 4, you would think of that as a stretch, right? But if it's on the inside, that's now a horizontal change because it's on the inside, and all inside changes are a change on the x-axis side to side. But it looks the same. So I have to think of it as a horizontal compression. So inside lies. I would think that a bigger number like 4 would make something stretch, not compress. But inside lies, so if I see a big number on the inside, it's going to compress instead of stretch. Okay. So again, this 0.5 is on the outside, so it's going to be a vertical change. If it's smaller than 1, if it's between 0 and 1, like a decimal or a fraction, that is going to vertically compress, which I would think that a smaller number would compress, like a fraction. But if it's on the inside, then it's going to be a horizontal stretch. Because inside lies. So a fraction between 0 and 1 would stretch if it's on the inside instead of compress. So it's important to remember whether it's vertical or horizontal. Everything on the outside, let me write that, outside is vertical, right? Because everything that happens on the outside is along the y-axis. That's the same for adding, subtracting, multiplying, negatives. Everything that happens on the outside is a change on the y-axis. Everything that happens on the inside is horizontal. It happens on the x-axis, right? The x-axis is the horizontal one. This marker's a little slow, but so inside is horizontal, that's along the x-axis. And then don't forget, inside lies, always lies. So if you expect a number to do something, it's probably going to do the opposite. Okay? So if I expect a bigger number to stretch, it's going to do that on the outside, but if it's on the inside, it's actually going to do the opposite, and it's going to compress. Because inside lies. Okay? So let's just write down a summary, I guess, quickly of what we have learned so far this unit. Let me see if I can get a whiteboard up here. I thought I could. Okay, give me 1 second. Well, I guess I can't. All right, so let's just summarize quickly. So if I have a negative on the outside, okay, that reflects the the function across. If it's on the outside, it's going to be an up-down change, so it's going to be across the x-axis. But again, that's still an up-down change, right? So if my parent function, x squared, is right there, then negative x squared is just going to flip that up, down, right? It's an up, down change because it's on the outside. Outside changes are always up, down. Okay? That's a negative, not just a line. So a negative on the outside changes things up and down. It reflects across the x-axis, right? Here's our x-axis, so it's going to reflect across that axis. If the negative is on the inside, it reflects across the y-axis. So that's going to be a side-to-side change, right? All the things on the inside are side-to-side changes, okay? So if I draw my graph here, here's the parent function of square root of x. And if I put a negative inside with x, it's going to reflect it to the side, okay? Then if I multiply a number on the outside, okay, if the number is greater than 1, bigger than 1, okay, if number is bigger than 1, then it's a vertical stretch. So if I draw my parent function here, if this is x squared, then when I stretch that, when I times that by a number, so this would be like 2 times x squared. It's going to be like stretching a rubber band. It's going to get skinnier. I guess not necessarily taller, even though it looks like it, because these are going to continue forever. So if I multiply it on the outside, it's going to be a vertical stretch if the number is bigger than 1. Okay, if the number is between 0 and 1, so it's a fraction, then it's a vertical compression. So the fact that it's on the outside makes it a vertical change because that's an up-down change if it's on the outside. Everything on the outside is an up-down change. So if it's a big number, it's going to stretch. If it's a fraction, it's going to compress. The inside is going to do the exact opposite of that. So let's clear this, and we'll write that one down. So if I multiply x by a number on the inside, remember inside lies. So if the number is bigger than 1, then it's a horizontal. So remember, horizontal is everything on the inside. Inside is a side-to-side change. It's going to be along the x-axis every time. And remember, it lies. So this time, if the number is bigger than 1, then it's a horizontal compression. You would think a bigger number stretches, but it doesn't. It compresses if it's on the inside. And if the number is smaller than 1, but bigger than 0, so it's between 0 and 1 basically, then it's a horizontal stretch. So if I have my function here, I'm going to put, again, well, let's do absolute value. So here's the absolute value of x. If I multiply on the inside of that, so let's say I do 1/2 times x on the inside, that's going to be a horizontal stretch. So think of it as taking the sides and pulling them out. So it's going to get wider. So it would look like this. But if it is a horizontal compression, it's going to take and push the sides in and make them skinnier. And that's going to be something like 2 times, whoops, not on the inside, 2 times x, like that. Okay. So those are the things that you need to know for today. Try your worksheet. If you have questions, then let me know. And then the key will also be there as per usual. Tomorrow we're going to talk about inverse functions. We will be reviewing on Friday and taking a test on Monday. The test will need to be completed on Monday, so make sure you're thinking about that and getting ready to do that. Okay? And have a great day, guys.